Okay, this is the solving quadratic equations. We started talking about this in class today. I said that I would go ahead and work all of these on a video and post it so that you can watch it over this weekend, kind of as you're studying for your exam. We will also be doing some examples from the worksheet that I passed out in class tomorrow so that you will get some practice with this in class as well. So what we learned is that, remember, this is standard form of a quadratic equation. Remember, quadratic means it has a power of 2 as its highest power. And in standard form, we want everything on the left and 0 on the right side. The reason for that is if we can factor that left side, then we will be able to set each piece equal to 0 and solve. That's called the zero factor property. So we put the quadratic equation into standard form, we factor it, we set each part or each factor equal to 0, and we solve for each equation. You should check each root in the original equation. I won't be showing that step, but checking just means plugging it back in, using your calculator to double check that it comes out correctly. So for this first one here, notice that we have x squared minus 3x plus 2. That is a trinomial, and it is got a 1 in front, so it should factor pretty simply into two binomials if it factors with x and x. We need factors of 2, so the only factors of 2 are 1 and 2, and they need to add to -3, so that has to mean that they're both negative, and they do still multiply to a positive because they're both negative. So this would be -1 and -2. We set each part equal to 0 using the zero factor theorem because this is multiplication. That is why this is what we were doing. We add the 1 over to solve this one. So 1 is one of our solutions, and we add 2 over to the other side to solve this for x. So we have two solutions for number 1, 1 and 2. For my next one, again, it is a trinomial with a 1 in front. It's already set equal to 0, so I can go ahead and try to factor it. And remember, this is different than factoring by itself, because normally if you factor, you just leave it in the parentheses. But since there's an equal sign, we can solve. So we're looking for factors of 4, which are 1 and 4 and 2 and 2, needs to add to -5 and multiply to +4. So it has to be -1 and -4. We set each part equal to 0, since it's been completely factored. We add 1. So that gives me +1 again for this one. We add 4. So I get +4. For my third one, I need factors. This again is a trinomial with a 1 in front, so I need factors of 16, which are 1 and 16, 2 and 8, and 4 and 4. It needs to add to -8 but multiply to +16, so those are both going to have to be negatives. Now in this scenario, you get the same factor twice. You only need to solve for one of them because they will give you the same answer. So this is x equals 4, and what we do when we have the same answer more than one is we actually write with a multiplicity. That means multiple answers of the same type of 2. Now you don't have to write that, but that's just so that you're aware that when we get to later chapters for 136, we're going to be talking about this a lot more. So I like to introduce it here when you actually see, oh, there's two of the same solution. So on a test, we're just looking for the answer x equals 4, but later on we'll tie it into this idea of it appeared twice. So that's what that multiplicity of 2 means. So I have r squared minus 12r plus 35. Again, a trinomial with a 1 in front, and it's set equal to 0, so we can go ahead and try to factor. So we need factors of 35 that add to -12. I'm not going to list all factors because I already have that in my head that that's going to be a -5 and a -7. So I'm going to solve each of those. Add 5. So one of my answers is r equals 5. Add 7 to move it over. My other answer is r equals 7. This one, all of these on this next row or this row that we're on actually are set up the same way, and they're already set equal to 0, so we're just going to factor. I need factors of 5 that add to 6. Well, the only factors of 5 are 5 and 1, and it needs to add to +6. We set each of those equal to 0. This time you're not adding to move it over, you will be subtracting. So we get -5 for one of the solutions, and we need to subtract 1 over to get the C isolated over here. So -5 and -1. For number 6, we have M and M, again set equal to 0 already. Factors of 9 that make 10, when you add them together, would have to be 9 and 1. And you're kind of noticing a pattern. I'm not going to write each step, because when you have this, if it's a factor with a 1 in front right here, when you move it over and solve it, all this does is change signs. So if you're starting to pick up on that pattern, you can skip that step and just write the 2 answers. Okay, for the next line, we start getting into binomials. So for the binomials, remember there's perfect cubes, perfect squares with subtraction only between them, and GCF. This first one looks like it's 2 perfect squares with subtraction, so we take the square root of both parts and we write that once with a plus and once with a minus. So that's still equal to 0. If I solve this first one, I get -7. If I solve the second one, I get +7. Z squared minus 4 equals 0. That's again perfect squares. This would be Z plus 2 and Z minus 2 equal to 0. So we go ahead and solve. So this would be -2 if I subtract over this 2 and +2 if I subtract or add over this 2. Again, similar result here. This is M plus 8 because they're both perfect squares, and M minus 8. So we get M equals -8 for the first solution and +8 for the second solution. Essentially what your solution is what would it take to make this parentheses 0. Now 10, 11, and 12 are not perfect squares right away. First of all, you have to look at them and say, well, 12 is not a perfect square and 3 is not a perfect square. But if you remember that you have to pull out GCFs, if you pull a 3 out of this pair, you are left behind with a perfect square. That would factor into x plus 2, x minus 2, and we have our equal to 0. Note that this part out here has no x. The part in front, the GCF, if it has an x, you do have to solve it. If it does not have an x, it's not going to give you a solution. So I do get a solution for this one. It would be -2 if I subtracted it over once setting it equal to 0. And just to remind you what I'm doing, I'm writing it down, but I'm doing it in my head, and then I would move that one over. So I get a -2 and a +2. Only if there's an x out front can you get a solution from that, or a variable. For example, number 11, they have a d in common. So you pull the d out. This is got a variable out front, so we set it equal to 0. Now, if it's just a variable out front, you're just going to get 0. There's no plus or minus anything. For your second one, you do have to add the 2 over. So 0 and 2. For this one, we can pull out an s, so that would be s minus 1, because you do still have an something in that spot. You just divided it by itself. So we get s equals 0, and s minus 1 equals 0, so s equals 1 or 0. Okay, now we're getting into the trinomials that do not have a 1 in front, so we're going to be using the factor by grouping method. Let me make sure I have some space. So for this first one, because there's no GCF and I can't pull out the 2, I have to do the factor by grouping or trial and error method. If you want to try that method, I prefer to do factor by grouping. So 2 times 2 would be 4. Factors of 4 are 1 and 4 and 2 and 2. They need to add to -5 and multiply to +4. So it's going to have to be -1 and -4. You then write that as, remember, 4 terms by splitting the middle. So -1x minus 4x plus 2 equals 0. It doesn't matter which one you write first. We then factor by grouping. I can pull out an x out of the first pair. That would leave me with 2x minus 1. If the second pair leads with a negative, you have to pull it out, and then they also are both divisible by 2. -4x divided by -2 would be +2x. +2 divided by -2 would be -1. Notice that this is matching. I don't have my highlighter, but this matches right here. So remember, that comes to the front as a GCF, and the leftovers in front of each of those 2x minus 1s become your second parentheses. Now this is different. This is the first time we've had something in a parentheses to solve that was not a 1. So when we set 2x minus 1 equal to 0, there's 2 steps to solve this. You have to add the 1 and then divide by 2. So one of my solutions is 1/2. And then x minus 2 equals 0 gives me positive 2. Okay, so for this one we do 3 times 3, which is positive 9. Factors of that are 1 and 9 and 3 and 3. To make negative 10, we'd have to use negative 1 and negative 9, which does multiply to positive 9. We split this into 4 terms. We try to factor by grouping, so I can pull out an x, so that leaves me with a 3x minus 1. Need to pull out a negative again, and they both are divisible by 3. If you divide that out, you also get 3x minus 1. So 3x minus 1 is one of my solutions, and the parts in front are the other solution. So this would be 3x minus 1 equals 0, so we'd add 1 over, so I'm adding it in my head, and then divide by 3. So 1/3 is a possible solution, and x minus 3 equals 0 would be the other solution, which means I just add the 3. So 1/3 and 3. Okay, so then we get into 15, which is 3 times positive 4, which would make positive 12. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. We need it to add to negative 8, but multiply to positive 12, so that has to be negative 2 and negative 6. I'm going to put the negative 6x first, just to show you that it doesn't matter which one you write first out of the pair. So this would be a 3x that I can pull out of the first pair, so that would leave me with x minus 2. I can pull a negative out, and I should if it leads with a negative in the second pair, and they're both divisible by 2. That also then changes that to a negative 2 when we divide this 4 by negative 2. And then we have x minus 2 is the match, and 3x minus 2 is the leftovers. Don't forget to keep bringing down your equal to 0, because that reminds you that you're solving these. So x minus 2 equals 0, and 3x minus 2 equals 0. This would be a positive 2 if we add it over. Here I do still have to add that 2 over, but then I have to remember to divide by the 3 out front. So 2/3. Okay, let's look at 16. We would do 5 times 2, which is 10. Factors of 10, there's only 2 pairs, and it needs to add to positive 11, but multiply to positive 10. So this is going to be positive, positive. So 5x squared plus 10x plus 1x plus 2 equals 0. So I split this into the 10 and the 1. Pull a 5x out of the first pair. The second pair has nothing in common. If that ever happens, you have to pull out a 1. And whether or not it's positive or negative depends on the sign right here. So that just tells me that they had nothing in common, but we have to pull out something. So that would make this x plus 2 and 5x plus 1 equal to 0. And negative 2 would be the answer for the first one. I always solve the fraction ones, but you start seeing a pattern there as too, is that it changes this sign and then you divide by this. So we subtract 1 and divide by 5. We did 17 in class. I'm not going to rework that one. 18, remember, you have to be equal to 0 to even start the process. So the first steps in 18 is to move the negative, the 9x over by making it negative and adding the 20 over. So this would be factors of 20 since this has a 1 in front. So 1 and 20, 2 and 10, 4 and 5. They need to add to negative 9 but multiply to positive 20. So that would have to be negative 4 and negative 5. So x minus 4, and I don't need to do factor by grouping, but I could. Factor by grouping will solve all the trinomials that are factorable. It doesn't solve the ones that don't factor, but it'll solve all the factorable ones. So this is just 4 and positive 5. Something similar happens with 19. You need to move everything over to the left, so you have 0 on the right side. You have a positive x, so when it moves over, it would subtract. You have a positive 30, so when it moves over, it would subtract. And then factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. we need it to be a difference of -1 because this is multiplying to -30. So I need a -6 and a +5. So I get -5 for one solution and +6 for the other. On this one I need to move the 15 over first. 2 times -15 is -30 again. We already know all those factors. And it's a -1 in the middle again, so that's going to be a +5 and -6. But this time this is a non-1 out front, so we do have to do factor by grouping. And I'm going to put the -6x first, because 6 goes better with 2 and 5 goes better with 15. Just personal preference. So I can pull a 2x out of the first pair. That would leave me with x minus 3. The second pair starts with a positive, so I'll pull out a positive, and they're both divisible by 5. That would leave me with x minus 3. X minus 3 is the match, and 2x plus 5 is the other one. Since I'm running out of room, the solution to that would be a +3, and you would subtract 5 and then divide by 2, so -5/2. That is one way you can write your solutions, is a list. For this one, again, you still have to move over the 50 first before you can factor. So -4 take away 50 more would be -54. Factors of 54, 1 and 54, and it's negative, by the way, 2 and 27. Let's see, does 3 go into 54? We need to check. So 54 divided by 3, not 6, is 18. So 3 and 18. 4 does not go into it. 5 does not go into it. 6 goes into it 9 times, and 7 and 8 don't go into it. So that's the whole list. The pair that would make -54 when you multiply but +3 when you add would be a -6 and a +9. So this doesn't matter which way I write it, but I'll do the -6 first. Minus 54 equals 0. Pull out an x in the first pair. Pull out a 9 in the second pair. Or no. Did I write that correctly? Hang on just a sec. Yeah, sorry, I actually made this problem harder than it needed to be because this is a 1 in front. I didn't have to do factor by grouping, but this is kind of a good thing because now you can see that factor by grouping even factors the ones that have a 1 in front. Sorry, it's late. So this is x minus 6 and x plus 9. We could have went directly there because this was 1 times -54, but I didn't need to do factor by grouping. It's okay. So this gives me a solution of 6 and -9. All right, let's look at 22 because we're almost at the end of this document. We need to move a few things over, so we need to subtract this 5 over first just to kind of get those lined up. So that'd be +2. And then we have this -5x that needs to move over. So if I add that, I will put it in the middle so that it lines up. 2 times 2 is 4 because this is a factor by grouping case. And 1 and 4 would be our pair. So 1x plus 4x plus 2 equals 0. Pull out an x, you get 2x plus 1. Pull out a +2, you also get 2x plus 1. Let's see if I can add a few more lines to that. There we go. And then the 2x plus 1s would come to the front as the GCF, and the x plus 2 would be the leftovers. So this would be -2 for this one, and 2x plus 1 equals 0. You'd subtract over 1, so that'd be -1, and then divide it by 2, so -1/2. Okay, this guy right here and number 24 are the most missed ones, mainly because people just try to set them equal to 35. They go, oh, it's factored, just set it equal. That rule only works if you're set equal to 0. So you actually have to undo this first and move everything over and then try to refactor it. So I'm going to move the 35 over by subtracting it. Now I can try to factor this trinomial. Factors of 35 that are 2 away from each other are 5 and 7. So this would be x minus 7 and x plus 5. and that means my solutions are 7 and -5. Same thing here. I cannot set these equal to this because it's not equal to 0. So redistribute and also move the 4 over by opposite operation, so -4. Factors of 4 that are 3 apart would be 1 and 3, or 1 and 4, sorry. That would be 1 minus y minus 4 and y plus 1. Multiplies to -4 but adds to -3. So I get y equals 4 and y equals -1. Okay, the last 6 problems are all special cases of things. This is what we call a proportion. It's a fraction equal to a fraction. Anytime you have that, you can use cross multiplication to solve it. It has to be an equal sign between here, though, not multiplication. So if it's an equal sign, you cross multiply if there are one fraction on each side. So we would have x times x plus 2 equals 2 times 12. The first diagonal equals the second diagonal. We would distribute this, move the 24 over, and we were going to factor that. That's at least got a 1 in front, so it's going to be a nice factoring. Factors of 24 that are different signs and 2 apart would be 6 and 4. If you need to make your list of your factors, do that. Positive 6 times -4 is -24. Positive 6 plus -4 is positive 2. So my solutions here are -6 and 4. For this one, again, it's a fraction equal to a fraction, so I'm going to cross multiply. Equals 3 times 6. So that's y squared plus 3y equals 18. Subtract the 18 over. That would be factors of 18 are 1 and 18 and 2 and 9 and 3 and 6. So 3 and 6 are the ones that are 3 apart, which we do need, but since it's a -18, they have to be different signs. Oops, I don't need the squared on that. Just erase it. There we go. Got ahead of myself writing. So this would be y plus 6 and y minus 3, since we want it to stay positive 3 when we add. So this would be -6 and positive 3 when you solve them. And in this one, you cross multiply, you get x times x is x squared, and 3 times 12 is 36. You still want to move this over so you can try to factor it. It turns out to be perfect squares. So we get x plus 6 and x minus 6 equals 0. So we get -6 and positive 6 when we set them both equal to 0 and solve. Which leads us to the last two, which aren't really any more difficult than any of the ones we've done. The problem is they've got a lot of terms and they just confuse students. You need to move everything to one side, so I'm going to move everything to the left in this case. So I'm going to subtract 9x squared over, lining up my like terms. I'm going to move this by subtracting x. I'm going to move this by subtracting 83. So that's going to leave me nothing but a 0 on the right side. This would be x squared minus 6x. 11 and take away 83 would be -72. Factors, since this is a 1 in front, factors of -72 that are 6 apart. So we have 1 and 72, 2 and 36. 72 divided by 3 is 24. I believe 4 goes into it as well. 72 divided by 4 is 18. 5 does not go into it. 72 divided by 6 is 12. And I have my pair, so I'm going to go ahead and stop. This is different signs. These need to be different because this is -72. This needs to be a negative and a positive. So -12 and +6 make -6. So x plus 6, x minus 12 equals 0. So we get solutions of -6 and +12 when we solve. Oh, one thing I do need to point out. Let me go back up to 25, 26, and 27. Notice that all of these had variables in one of their denominators. That means this answer could not have come out to 0. I forgot to mention this. If we had gotten a 0 for an answer, we would have had to thrown it out because that would have created 12 divided by 0 or 6 divided by 0. So since all of our answers come out as they're not going to plug in and make this turn into a 0, we're okay. But that is something you have to worry about with the fractions. Okay, so for this one, I'm actually going to move everything to the right. That's okay as well. You don't have to always go to the left. I'm just trying to keep my x squareds positive. So I'm going to move everything to this side. So this is 0 equals 2x squared minus 10x, and 60, negative 60 plus 12 is really subtraction. That would be negative 48. Now, you would think, oh, I have to do factor by grouping, but remember, always check for a GCF. You can pull a 2 out to the front, and that makes this smaller and easier to factor as well. So this would be factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 3 and 8, if you are using a negative 24, which we are going to subtract to negative 5 if you make the 3 positive and the 8 negative. So then remember, this guy gives me no solution because there's no x here. So this one will give me negative 3 as a solution, and this one will give me positive 8. And that is it for this worksheet.